Now we have the second property, that is the reaction with oxygen. We know that anything which reacts with oxygen, it forms oxides. So they also form oxides, but the respective formula for their oxide is basically EO2 or EO3. Right. So we will start with sulfur here, because we know that the oxygen forms the, it means there is a reaction with oxygen, and oxygen again is an O2 molecule, right. So we will be starting with the sulfur first. So we see that they form oxides di and tri. So we see that sulfur forms sulfur dioxide, selenium forms selenium dioxide, tellurium forms tellurium dioxide. So as far as the states are concerned, we see that SO2 is a gas and they both are solid. The reason behind that they exist as solid, because there exists a chain like structure in them. There exists a chain like structure. And if we talk about their nature, so they are acidic in nature. How we can prove them? We can prove by reacting it with water. We know that SO2 when react with water, it forms sulfurous acid. Likewise, selenium when react with water, it forms selenious acid. It is selenious acid. And but when we dissolve tellurium oxide and dioxide in water, there is no reaction. There is no reaction, even by supplying any external factor, also by altering any condition, it do not react, but somehow it reacts with acidic and the alkaline salts, right, but otherwise it does not react with the water. So if we talk about the reducing character, we see that here, because as we are moving down, as we have seen that gas state is changing to solid. So that means they are having strong force of attraction, the reason being the chain structure. So we see that that means the reducing character is somehow decreasing down the group. It is decrease down the group, the reducing character. Similarly, if we talk about the geometry for SO2, we know that it is a bent kind of geometry. We know that geometry is something like this, that is the bent or angular one. Likewise, we have another the trioxide, that is sulfur, and it is SO3. If we look for the geometry, it is like this, that is trigonal planar. It is trigonal planar, right. And selenium again forms selenium trioxide, but as far this is gas, but as far as the states of these are concerned, they are again solid here. The reason being they are not existing as a single molecule, they combine with number of molecules, like selenium trioxide exists as tetramer. That means 4 molecules combined together to form the solid kind of crystalline solid kind of structure, and the structure is something like this. A chain kind of structure, as you can see. Similarly, if we talk about tellurium trioxide, it exists as a dimer. The 2 molecules get attached in order to form Te2O6. So this is how they react. That means they form dioxide and trioxide. You know about the geometries also. You know about the acidic character also, and the reducing, the same happens here. The acidic character again decrease down the group, the reducing character again decrease down the group, because we see that the state is changing from gas to solid, because they exist in a chain kind of structure. That means they are strongly bonded. So that means the reducing and the acidic character decrease down the group. So this was the second property. Now we are going to start with another property, that is the reaction with halogen.